Now that we're recording, and you can see that we're recording, we want to do this in polar coordinates. Cartesian coordinates will ruin your life in this particular situation. Circles need circle coordinates, squares need square coordinates. Everybody's happy. Okay. The first thing we want to do is we look at the picture and we want to figure out what does the electric field vector at that point look like. Okay, so we're going to start by looking at this. So for this part, which way should that vector point? Like when you add them all up, which way should it point?
To the right and down.
Sort of to, yeah, like this, right? So sort of like that.
Yes. Yep.
Okay, how about the blue guy?
Up to the right.
Up to, yeah, the same exact line, but up to the left. Okay, up to the right, whatever. You get the idea. Okay, fun fact about these, the total one, what's that going to look like?
Just to the right.
It's going to look like this, and it's going to be big, right? Yeah, and I changed the, okay, now should look something like this. And the reason for that, just like before, is you can break this one into this and this, and you can break this one into this and this, and once again, these cancel, okay, so we can get rid of them, and these add, and they give us this red guy, okay? Once again, this is our theta, but we're in polar coordinates now, so we don't need to make theta into x and y anymore. It's a beautiful time to be alive, okay? Yeah? All right. So once again, we start with Coulomb's law in the differential version, which is dE is equal to k dq over r squared r hat. Remember, this is a vector, and that is why our life is so difficult, because vectors make everything harder. You can't just add stuff together. You have to add it as a vector, which means it has to either be going in the x direction or the y direction, even though we're using polar coordinates, because the coordinates of polar coordinate vectors much more complicated. Let's just stick with x and y in this case, especially since we know our answer points in the positive x direction. So even though we're using polar coordinates, we still have some links to x and y, okay? So we know our answer looks like this. So we're going to start by just going through the chunks of Coulomb's law. And because we know this is in the x direction, let's rewrite this as dEx, which is k dq. This is all the same, over r squared. But that will now be sine or cosine? Cosine, because this is adjacent to the angle. So that's going to be cosine theta in the x hat direction, and it's positive, so we don't have to deal with all these negative signs, okay? All right, so that's pretty fun. What else do we need to do? Well, we need to figure out dq, and we need to figure out r, and then then that's it, actually, because cosine theta, do we need to change cosine theta in this case?
Isn't
No.
R constant?
R is constant, which makes things nice. Why is R constant?
It's the same.
Yeah, because for any chunk you put here, the radius is R, right? Because it's a circle. Circles are neat. Okay. Happy Pi Day, everybody. This is a gift from circles. Okay. So when we write this out, we get k, that's just a constant. We still need to worry about dq, but now r is just r squared, and we have cosine theta and x hat. Okay, so let's worry about dq. So if you take a little chunk of this guy, that's dq. But what is the length of this if we're in polar coordinates? Before it was dx or dy? ds. It is arc length. So we know we can call this lambda ds for arc length. But remember, what is an arc length in terms of r and theta? S is equal to r theta. Well, actually, little r theta, because it should be a variable. However, we know our r, is not a variable, it's a constant. So when we take ds, it becomes capital R d theta. Because we're really, these little d's are like a derivative. I mean, you can rewrite this as ds d theta equals r. if you really want to, if you're like a pedantic math person. But in physics, sometimes we just are like, oh, here's a derivative of s, and then we just take the derivative of theta, and then we just write it that way because we're cooler than the math people. Don't tell them I said that. Okay, and then this is lambda r d theta because reasons that we just said. Okay, so that's what we need for over here. So we come back over here and we have k over r squared. Now we have lambda. And do we need to convert lambda to anything? No, it's very convenient because, and why do we not need to convert lambda to anything? Because it's already something we're given in the problem, okay? Lambda is the value we're given. Last time we were given Q and L, which was annoying, so we had to convert lambda into the stuff we were given. If we're given lambda, don't mess with it. You look like you have a question.
Yeah, why is lambda constant?
Why is it constant? Because it said it was constant. Yeah, it's constant. If it were not constant, it would be a function of r or theta.
So if we were given like a charge.
Yeah, oh, here's some nightmare fuel for you. You can have non-constant densities. Like you could have a density that's a function of r and theta, which would make your integral a lot more unpleasant.
Yeah, but don't do that.
No, it would just be a different, you'd have an extra variable, not an extra variable, the same variable, but you would have like r squared, or, if it varies by, in this case, it couldn't really vary by r, but it could vary by theta, right? So you could get more dense stuff as you get into higher angles. That's a mess. We're not going to do that, but I just want you to understand that that's a thing that can happen so that you can appreciate that I didn't do it to you. Okay. Yeah, good. Okay. So then we just do some cleaning up over here so we could see that one of these r's goes away, and we pull out all of our constants. So we get k lambda over r, and then we have this as an integral because this is going to be ex. Okay, so really we're just integrating this. And at some point we're going to have to multiply this by what? 2, because there's 2 of them. We haven't done it ahead of time this time because it bothered us the last time. So we'll do it at the end, but don't forget. So we'll just write multiply by 2, please. Leave yourself a note. If you do this on the test and you forget to multiply by 2 and I see that, I'll just give you full credit for being smart and reminding yourself later. You don't have to say please, but I like it if you do. Okay, so this becomes cosine theta d theta. This is still in the x hat direction. What are our limits of integration?
0 to pi over 2.
Pi over 2 over 0.
You can either go from 0 to pi over 2 or from pi over 2 to pi.
You just have to flip the sign.
You just have to flip the sign. It should work the same way. As long as you take the absolute value, since we know the direction, it won't really matter, okay? I'm just going to go from 0 to pi over 2 for funsies, okay, because it's a little bit easier. So this becomes k lambda over r. The integral of cosine theta. Anybody know that one? Hey, sine theta. Look at this. Look at us doing calculus. Take that, math department. Okay, so when you plug those in, what is the sine of pi over 2? 1. What is the sine of 0? So what is 1 minus 0? 1. You guys are killing it at math today. Okay, k lambda over r. That's it. That's all we got. And it's in the x hat direction. But remember, our E total, which is also a vector, is 2 times EX, right? So we write this as 2k lambda over r in the x hat direction. So that's our E. And now we are done. Okay, so not all of these have terrible integrals that make you wish you were dead, but some of them do. What's up?
So I'm not saying that I'm proficient with this stuff yet, but say this stuff is easy for us before the exam. How long should that exam take us? Like an hour or so? I know we have 3 hours.
I write the exams so that I can do them in 45 minutes or less. So if you can be where I'm at, you should be able to do it in 45 minutes or less. I mean, actually just writing out the steps takes a certain amount of time, so you can't do it much faster than that without it being sloppy. Yes.
Will we just like get deducted 1 point if we forget to put like the x hat y hat direction? Is it just a 1 point deduction? Or is
Yeah.
it half of this because it's
Oh, like if you forget this guy?
yeah.
If you forget to put X hat or Y hat, if you put it somewhere else in the problem or like drew this arrow, I'll be like, it's not cool. And I'll write you a note that's like, don't do that again. But if you show me that you understood which direction it should go, I'm not going to mark you down.
Okay, but if you just didn't have
But if you write nothing indicating any direction, I cannot help you.
so it's just literally half. Is it half of like how many points would we be deducted in since it's asking for like magnitude and direction?
No, just 1 point.
Oh, okay.
Like, unless it clear, like, no, the way, if you look at the rubric, like, if you look like you know what you're doing, but I don't have any indication you really knew the direction, but you did all the other stuff right, that tells me you probably knew the direction and you just forgot to write it down, and I would just give you a 9 out of 10. If you look at the grading scale, like, it's more like squishy. It's like a 5 out of 10 isn't like you got half the answer wrong. It's like you don't really know what you're doing, but at least you used the right equation and you wrote some things that looked like physics. So it's more, that's how I grade. Yeah. Any other questions before we move on with our lives?
It's 1 page of notes allowed in the exam, correct?
Sure.
And back.
No, yeah, it is. Yeah. Yeah.
For front and back?
Notes are for the week. Yeah, it's front and back.